Cool. So it looks like we just hit our official start time, but I still see a couple students kind of pouring in, but we can probably go ahead and get started, maybe do our introductions and just get things rolling here. So first of all, thank you everybody for joining our session here. I'm Kyle. I'm a professional IndyCar driver as of 2019. I will give you a little bit of background about maybe my story, how I got into racing when I first started. Like a lot of professional drivers, I got into racing when I was 7 years old in go-karts, just kind of started off originally as a hobby. Eventually, as I got older and I started racing faster karts, I had the dream to race in the Indianapolis 500. That was kind of my main objective. So as I got older, started getting in faster cars, the goal was to raise sponsorship, to work my way up through the ranks and get into IndyCar. I was fortunate enough to raise sponsorship money and be able to race on the road to Indy. Eventually in 2017, I won the Indy Lights Championship, which promoted me into IndyCar in 2018 and 2019, and raced in the Indianapolis 500 twice. So very fortunate and grateful for those opportunities. And I'm going to hand it off now to Matt, who works on the IndyCar side of things, who's going to give his background.
Hi there, Matt Greco. I've been with IndyCar now since 2012. I'm the senior software developer here. Pretty much anything data related that we have in-house that we do comes through some sort of application that I've written. Whether it's timing data that comes in from the race cars, telemetry that comes in at about 120 messages a second per car. Anything that you see on TV, any of that data that's coming through me, stuff we use with race control to officiate the race, know when a car is speeding in pit lane, when they've hit a shortcut on the track, if they're getting close to getting lapped down by a car, anything like that. I've got programs that I've created to be able to do that.
So I guess like what this talk is going to be about is really how technology plays a role in racing. To the casual observer and for people who might not be race fans, it really just looks like there's a car and a driver on track and they're just going around hitting the gas and turning the wheel. That's obviously a very dumbed down version of what racing is. And in reality, there's entire teams behind the scenes that are collecting data, analyzing that to make sure that the car is operating at absolute peak performance. And without being able to collect that data and use that, there would really be no way to know how close you are to the limit. And the obvious goal of a race weekend and racing in general is to make the car go as fast as possible and be faster than your competitors. So to kind of summarize, my job as a driver every weekend is to make sure that I'm making the car go as fast as the car can go, but we have a variable input with the car. We can make changes to it. We can do things to make the car's limit higher than anybody else in the competition. So in a way, it's kind of like solving an impossible math problem is kind of the best way that I can think about it. Our job every weekend is to show up and try to make the car as perfect as possible using whatever tools at our disposal. So just kind of logical next question, what tools are at our disposal to make sure the car is going as fast as it could be? One of them is really collecting the data of what the car is doing on track. Because a lot of times I'm out there, I'm doing my thing and I'm driving. I come back in and everybody wants to know, okay, I can tell them what I think happened, but there's an ultimate source of truth that they have. And that's all the sensors and computers that they have on the car that track every movement and motion that I do as a driver, but then also tracks what each part of the car is doing in order to create a perfect idea of whether the car is at its absolute limit. I use that data for myself to tell whether I could push the car harder. The engineers use that data to try to see what changes they could make to the car to make the car perform better. Now, what's really interesting is that and I'm going to have Matt pull up a picture here of the steering wheel. Now, the steering wheel is probably the most important part of the car because without that, the car's not turning. But what's so interesting is over time, the steering wheel has gotten so complicated and actually has so much software and technology integrated just in that gives us a lot of options to make changes and do things that influence the car, as well as communicate data to us while we're driving to influence decisions that we make. And I almost would love to pull up a picture of what a steering wheel used to look like 20 years ago. But I mean, obviously, we don't need to see a picture of that. It's literally just a steering wheel. You're not going to see anything other than maybe a bar of lights on the top. So steering wheel technology alone has come such a long way. So what I'm going to do really quickly is maybe just talk about what is on this wheel. What do all these switches and buttons do? And how does that impact what I'm doing in the race car? Just some of those buttons on the top left there. You see that we have push to pass, that's the OT, overtake. We got a radio button for communicating with pit lane. We have a drink button in case we need to take a drink of water. So there's some things that are more manual inputs, but probably the most important dash here is what is right in the middle. It's displaying the data of what the car is doing, what gear I'm in, what RPM we're running. It also tells me which settings I have for my sway bars, for how the car is going to handle. And what's so cool is that the engineers on our team can customize these pages to pretty much read and display any information that we want, whether that's distance to the car in front or behind, what timing should I do for changing gears based on how the lights auto-populate on the top. There's really an infinite amount of things, and it takes a lot of creativity and kind of game planning with your engineering team to get this wheel and display to fit exactly what we need from ourselves in the car. And I'm sure that you can imagine there's different engine modes and mapping that the engine manufacturers tell you to set it at different times if you need to save fuel. So all of those things are controlled just through the steering wheel here, which is, I think, just incredible how far that technology alone has come over time. Now, what I think will be cool is to switch over. Matt has a cool video from the Indy 500 of the first lap, kind of showing how maybe some of this technology and some of the things that we use as drivers are put into play. So if Matt,
hey, before I do that, I got a question for you. Is there something?
Fire away.
Is there something that you've wanted to have on the dash that your engineer told you, no, you need to focus on driving rather than getting that information?
Oh man, yeah, I would say, a lot of the times, a lot of the data that we're using in the car, I want to use most of it when we're under like yellow flag conditions. That's when I have more time to actually look at the dash and kind of see like how much fuel saving we're doing. Actually, that's one big one. Is like when we're under yellow conditions, staying within the correct range to save fuel is a really big challenge. And we set it up so that the lights on the dash would turn green whenever I'm in the perfect range. They would turn yellow when I was going too fast, or red when I was way off. So like I need to change gears to get it so that it's green, so that I'm saving the optimal amount of fuel.
Yeah,
that was something that we took a lot of time to work on, because that can be super important in the races. But I can't think of anything specifically that I could think of where they're like, we can't do that. They'd always be able to do it. It's just, do I have the time to switch through and actually look at it?
Yeah, I've heard other engineers, or I've talked to them, that said, no, we don't want our driver to know that information, because then they focus too much on it and then they're not actually driving the car.
That makes sense. But I think that's up to the driver to just like not be staring at your dash while driving too often.
Right. Yeah. So here, let me start this video. All right, so this is the first lap from last year's Indy 500. So I believe we're on with Colton Herta here. So he started second. When you're in this pack up front, what are you thinking? What are you watching?
So the main thing is for the 500, the Indy 500 is the most difficult start of probably any race of the year. You're going 3 wide going into the corner. The way that the aero affects your car is worse than anywhere else, because you have pretty much the entire road blocked by cars in front of you. So if you're starting second for the 500, you're in pretty clean air. You're not too concerned about what's going on around you. Your number one goal is to just lock in, fall in line with the car in front of you, and just roll from there. Now it's kind of jumping around here between different cars. Now this is kind of a mid-pack start, it looks like. When you're in the middle of the pack, in 2018, we qualified 17th. So I was pretty much dead center right in the middle. And I remember that the aero impact going into the first corner was pretty significant, but not as bad as when we started dead last in 2019, when we were the last car. You felt like when you're going into the first corner, the car wouldn't turn at all. Yeah. And a lot of that stuff, you can kind of predict and tell how the car is going to react based on the data that you've collected from all of your sessions before that, and practices and stuff. You could run a session in a big pack and go in and see, well, how did that impact how the car steered? You can see how much steering wheel you had in the corner and have an idea of, okay, if I'm behind a ton of cars, I have an idea of how much I can turn the wheel based on what I saw in data.
Yeah, so I mean, look at that. You see Ray Hall had 4 cars in front of him there.
Yeah.
And you can see he probably had to hit the brake because he had guys going by him here. One of them coming up, and I think it was Newgarden, and we might see McLaughlin do it here. They started going outside. Yeah, you can see it here. They start going on the outside now on these restarts. Kanan used to do it all the time, but now more and more of them are doing it. Have you done that on any of these restarts that you had?
You do it whenever you can, but it's risky because oftentimes it depends on how far you are into the race. Earlier on in the race, the track is kind of the same for everybody everywhere on the track. So if you want to go the outside line, it's probably not too bad. Later on in the race, there's a very rubbered in line that has a lot more grip than offline. So if you try to do that too late in the race, you find yourself in trouble because there's no grip out there.
Yeah. Even when because on a restart, probably going into turn one, you're about what, 180, 190 or so when you hit turn one?
Depending on where you are. If you have a huge toe and you're in the back and you're able to just go full throttle, you could get up to the 200, 210.
Okay. But still,
it can
still
get pretty
slow.
sketchy.
I say slow enough that you can go too wide through that turn, because when you're full on, even a second lap of a run, you can only go one wide through turn one, and really through all the turns, right? Can you go too wide on any of the turns?
Yeah, absolutely. I mean, it depends on when in the race, kind of like I was saying, but see, sometimes you can go 3 wide. If the track is rubbered in enough and the conditions are right, you could probably go 3 wide at Indy.
I see, it looks like those guys are standing still, and they're not. They're not standing still at all.
So I know you wanted to talk about kind of the proximity of cars to each other on the racetrack and maybe how that plays a role here. Could you maybe go into how like live timing and the proximity of the cars and some of the stuff that you're working on the technical side as on live timing?
Sure. So what you can see as we go around, so around the track, we have timing lines that are in the actual asphalt that go. Let me cancel this here. We'll just keep it up for a roll. We'll get rid of this. So as they go around the track, actually, we'll just restart it. We'll run it again and let them watch while we talk. There's timelines around the track. So they're actually in the asphalt that when a car goes over it, they have a transponder inside that sends a signal back to us. We've got central servers that sit in a truck that then we're able to process all that data from there. What we're able to do and to send back to the car, the way the transponders work is they're actually two-way. So it can talk to us through the timing loops, and we can send data to the car as well. So we give them the flag condition, so what flag we're showing in our timing system, how many laps they've run, their last lap time. We send to them the gap ahead and gap behind of the car in front and behind them. And we also tell them which car that is. One of the engineers, when we first started this, said, hey, could you add the car number? Because some cars behave differently when you're running behind them. So we'd like to know who it is. I don't know if that has to do with rookies and veterans too, that if you're sitting behind a rookie, they're going to do something potentially different than someone who's been at the track before. We also send weather data. So these cars are extremely weather dependent, especially on a track like this. The wind speed can change your miles an hour by up to 20 miles an hour on a straightaway, depending on which way the wind's going. We can see, it's especially true in qualifying, we can see cars going over 240 miles an hour going into either turn one or turn three. And on the other side of the track, they're only, again, I say only, they're only doing about 220 going into that turn, just based on a 15 mile an hour tailwind or a headwind. So we're able to tell the cars and put it into the team's data what the weather conditions are. And I think we were talking about stuff that goes on the dash. The teams can then put that data on the dash so the driver can see how close they are to the next car. Now you said you only use that under yellows. Was there any point, 3, 4, 5 laps into a run where you're like, all right, I'm now half a second behind. I need to catch up at this certain interval to get to pass him in turn 3 or pass him on the front stretch? Was there any kind of indicator on there that you would use?
Yeah, and oftentimes we would do that to see our gap to the car in front, but then we would also have like a set lap time that we'd want to hit, like we'd have our own delta. And that's probably the most active thing that we use while we're driving is, okay, how far off are we off a certain delta lap time that we need to hit? Are we ahead or are we behind during the lap? So pretty much coming out of the corners, you look down and check, okay, I'm on pace to hit my delta or I'm off pace.
Yeah. It also tells you how close you are to the leader too, so you can make sure that you know how far behind you are in the course of the race. So now the other thing that you guys have going on while this is going is you have not one but 2 spotters that are sitting up in each of the turns. What are they telling you as you're going around?
And that's kind of a big aspect of racing that is driver dependent. Some drivers like their spotters to be very active and tell them who's around you at all times. Some drivers prefer just to handle it mostly themselves and just don't have too much chatter on the radio. I was somebody that really liked to lean on my spotters. I thought they were a good asset to have up there in the, on the upper corners. I would have them usually give me every few laps how far is the car behind, even though I could see it on my dash. Sometimes they could give me an idea of the closing rate, on the straightaway. Oh, it looks like this person's closing, be prepared to defend if you need to. So they're definitely a good asset for the drivers, but it kind of goes paired with the technology that we have in the cars.
Okay, I think we're good.
Now, before we kind of like officially started, you were telling me about some really interesting encryption tools that you guys were working on in this off season. Originally for the drivers, obviously during the off season, usually our least busy time of the year. It seems to be the opposite for the engineers, and definitely on your end. Maybe you could go into some of the things why you're more busy during the off season than during the season.
Sure. So one of the biggest things during a season is that we don't want to break anything that we're using on the racetrack. So anything that's going to help put on the show, whether it's in race control or sending to the teams or sending to TV, we don't want to have anything break and go down during a race, because our main focus is to make sure the races go off without a hitch. We always like to say, when you don't hear about timing and scoring, we're doing our job correctly. But one of the things in the off season that we do is we're able to introduce new things and be able to break our systems to be able to rebuild them, test them, and make sure they're ready to go for the next season. One of the things we're working on now is a new data distribution platform to send to all the teams, to TV, our web folks, and anyone else who is a stakeholder with our data. And as I was telling Kyle beforehand, the project that I'm working on right now is with our telemetry data. So we have 4 kind of subsets of data that we use. One is what you would see on our INDYCAR app. So if you would go on during a race, you can see the RPMs of a car, its speed, the gear it's in, brake, throttle. Those are the basics. We just call them basic telemetry that basically anyone in our paddock has access to for all cars. Since we give it to the general public, we make it available to our teams as well. So there's a subset of that telemetry data. Then you have the next one, which is for TV. So they have a few extra things that they have. So GPS coordinates of the car, how far along the track they are, a couple various things, some G-forces so that they can show G-forces on TV. Just a couple different things that TV can use, but we don't send that out to everybody. We have tire data, so tire pressures, temperatures, which tires are on the car, which type of tires on the car. That's done for Firestone. And then we have kind of the catch-all for everything else. So the biggest one there is fuel used. We're able to track the fuel used from each car, and overtake. So knowing who's using overtake at what time, how many seconds they have left, all of that. So the challenge that I have is taking these 4 data sets and figuring out who has access to which one and encrypting it specifically for that group. And as I was explaining to Kyle, what the theory that I have that I think I'm going to use is to try to if you start at the top end, so if someone who has access to all the data, you give them an encryption key to get that. Once they encrypt the most secure one, it has in there the key to the next one. And then that one will have the key to the next one. And it just kind of cascades down until you get all of the data that you need. If you just have access to the basic one, we just give you the key to the basic one. It won't work for the other ones, but will work for the basic one. So I have one data file, which is the other challenge, is, as I said, it's 120 messages per second per car that I have to then make into a file that I have to be able to share across the internet. So, a gig to a gig and a half max is usually what we want to do, because anything above that, it becomes cumbersome for a program or for a user to use. So we want to try to keep it below that. So that's the challenge that I have, is making one file so I don't have multiple files to keep track of, and then making sure that the correct people have the right access so that there's no competitive disadvantage that some team is getting telemetry data from another team, which would be a huge no-no and something that we definitely don't want to happen.
I think that's so fascinating. And how did it work before, or the way that it's currently working? Do you have to send multiple files out?
No, so honestly, there's not a whole lot. We have, it's just a data stream of data. So in normal practice, what we've had now is we give an IP address and a port number to all of our teams or anyone else who wants the data, and they just connect into it and they can capture the data, and it goes into a text file for them to be able to replay. That's available to them, and we just give them the data file that's that way. Our new system will have login capabilities. So now they'll be restricted to what they're able to do. But really, this is more for the higher level stuff that we definitely don't want getting out.
Yeah, no, that makes sense. So before it was just more open for everybody to see the
Right.
data. Where now it's
So
more,
right now we have different streams for different people who take it. So TV has their own data stream and they have their own network. So we know the TV people have at the track, they're on a VLAN, a network that they have where only they have access into that network. So we know we're pretty secure that somebody has to be on that network and know all the details to be able to get it. So we're pretty confident we can do that. Same with the full telemetry. It's only available on our corporate network that the teams don't have access to, the TV doesn't have access to. So again, we feel that way, but there's always that, you never know, like somebody could plug in even accidentally and like, oh, I didn't know I had this. So it was just another level of security.
all right, perfect. Well, I guess I'll transition here into maybe driver debriefs. I did see one of the questions that we're kind of talking about. How do you use some of the technology or some of this data to affect some of the equipment? And it's kind of a roundabout way, but I'll kind of give a little introduction into how that works. Because one of the most important parts of the race weekend for the driver and the team kind of happens behind closed doors, and that's called the debrief session. That's basically after every single session that you go out and do, you want to get the team together to go over how did the session go. You usually had a run plan. You want to look at, okay, did we hit our objectives? How did we stack up to the competition? We're using some of the data that Matt was just talking about to really compare to how the other teams performed and their timing compared to what we did in different sectors and whatnot. But then also looking at what did we track within the car with the sensors that we have? Did the car perform how we wanted? Now, what we do is before the session is the mechanics will usually make changes to certain parts in the car. And in this example, I'll just talk about the ride height, which basically is the distance from the bottom of the car to the ground. It's probably one of the most important changes that you make by adjusting the length of the push rods that connect to the wheels. It lowers the car up or down from the road. And it's actually a really creative way to create more downforce on your car. I'm not going to go into the physics. Personally, I don't need to understand that. All I know is that the car is lower to the ground without touching, you're going to have more downforce on the car. So there's a balance between getting too low so that you're not touching, being too high to where you're not getting enough downforce. There's a really happy medium. And before technology or before you had this way of tracking that, it was kind of just a feel. You go out and the driver says, yeah, that felt really good. And that's kind of all you had to go off of. In the debrief room, they're making these changes to the car. You go out and then you go check the data and you say, okay, how far in millimeters were we off of the ground at every single part of the track? And that can dictate, okay, we were touching at this part of the track based on our sensor that shows we touched the ground once here on this lap. So they'll go back and tell the mechanics, okay, we need to raise the car this many millimeters so that the car is at its optimal ride height level. That's just one example of one part of the car where the engineers are using data to impact how they're going to set up the equipment, how to maximize performance out of the car. And that happens pretty much after every session. There's sometimes multiple engineers that focus on just one part of the car. So it's a true team effort, and how you coordinate all that and get it to come all together to get the best possible car and extract the maximum performance is kind of the ever ongoing challenge every race weekend for a driver in between the race team. And Matt, I think maybe we should take a quick break to do a little Q&A, maybe do a little Q&A pause here, because I see that there's a good amount of questions that have been popped in there. So it might be fun to answer some of the other questions here.
Yep, I've got a good one with a good story here. So Forrest asked, what happens if a system fails while on the track? So this would have been 2015 or 16. I don't remember exactly which year. We're at Long Beach, and the way our overtaker push to pass systems works is that we send basically an enables command to the car to tell it when the driver is able to do it. Because in our rules on starts and restarts, the drivers aren't able to do it until they're a lap into the stint, till we're a lap under a green flag. So we have this in here. I tested it over and over, and we've been doing this now. It might still be the first year, it might even been the second year. So this has been tested many, many times. No issues ever with this. We get going, and we're about lap 30 in the race, and all of a sudden, our timing system, we lose like half of the track of our timing system, that we're not getting data from the cars. And we're flailing around trying to figure out exactly what's going on. Well, we finally figure out, 4 or 5 laps later, that a camera guy went into a camera hole where he was not supposed to be. So there was a robo camera there and was supposed to be off limits for humans. but he decided he wanted to go there to get this shot of a camera. So when we have a robo-hole where humans aren't supposed to be, we're able to lay cables down without having to worry about people being in there. Well, because there was somebody in there and he was trying to leave, he tripped over a cable and ripped out some fiber. Great. So now we go and we have to go and replace it. Well, in our timing system, when we do this, we get all the data that was there and collected and brought back in the system. But the problem is that when it does that, and in the programs we have, I hadn't taken into account when we put in this old data into it to be able to run this. So what happened was it basically crashed my overtake program. So I had to restart it. Well, when I restarted it, it popped back in that it turned off everybody's overtake for about a lap until it finally fixed itself and got all the data back into it. Fast forward now, so we get through the race, everything's fine. I start going through all the data and see, okay, nobody would have been disadvantaged by having it enabled while somebody else didn't, because that was my biggest fear, is that somebody behind had it enabled and somebody in front didn't, and they were able to make a pass because of our fault. It's basically our fault that it happened. Thankfully, none of that happened. We were able to answer all the questions that teams had about what happened. Well, it wasn't good enough for the driver of the number 9 car, Scott Dixon, who was adamant that he got passed because the guy behind him had it while he didn't, just because of how fast he was going. So the next weekend, I had to go and answer to Scott Dixon and all of his engineers, everybody at Ganassi, basically, about what happened. Here's the data. Here's everything that's there. It was not terrifying, but it was one of the first times that I had sat down with a driver. And of course, he's one of the biggest ones we have, and have to explain, one, that we messed up, there was a problem, and you just have to talk through it and you have to get through that. So now, if there's any photographer who wants to take out wires at any of our tracks, we're very prepared for it, and that won't happen again.
No, that's a great story, and that just kind of goes into the reality behind, yes, there's technology, but human error happens. Things happen at the track that can cause problems, and being able to pinpoint where that error took place, it's really fascinating.
Yeah.
Now, I saw an interesting question here. Let's see if I can find it. Oh, yeah. Can sensors help during a crash or an accident on track? And I think that actually ties a lot to what Matt does, also to what I do. Every time there's a crash on track, we see the yellow flag pop up on our dash. And I think that's right in your wheelhouse, isn't it?
Yes. So in race control, there's a light switch that goes on, and we actually have our timing system tied into that switch. So in the electronics underneath, it sends a signal into our timing system. So immediately when the light is switched, we have that exact time. So there's never any question as to where cars were or what time the yellow came out. It's exactly when the lights turn on, whether it be in the car, around the track. Both of them are tied together.
And I guess I have a question now, because I know there's been controversies in the past about when the yellow flag came out before a certain timing line, whether a car passed under yellow. Could you explain maybe an example of how a car may have claimed to have been ahead at a certain point, but the yellow came out and they had to give the position back? I know that happens sometimes with reshuffling the field based on the timing lines.
Correct. Yeah. So again, like I said, there's anywhere from 11 to 20, depending on the racetrack. We try to have them about 3 to 4 seconds apart. So if you make a pass in that 3 to 4 seconds, and the only time we know where your car is when you go over a timeline. So that's when we go yellow, we just go back to the last known location of your car. Sometimes you're able to do it with video, but sometimes the angles aren't quite right, and you can see perspective that it just doesn't work with video. So we just go back to the last green timeline. So if you make a pass in that 3 to 4 seconds and it's just unlucky timing that the yellow comes out during that time, you have to give the spot back.
Yep. No, I know that there's been controversies, but at the end of the day, whatever the data says and whatever the sensors say, that has to be your source of truth. And it's pretty hard to argue that.
The biggest one was long before I started.
Yeah, seriously. Another good question that I actually do not know the answer to, because I'm younger, but somebody asked, how long has data or coding been in racing? And Matt, do you have an idea?
We've had an electronics timing system since 2000, I think. So I think at least since then, we've had at least timing transponders. I know the company we buy our equipment from started in the late 90s. So I know it started like 95, 96. But before then, it was every car had to provide a person to score another car. So when we have the Indy 500 with 33 cars, you'd have 33 different people who would score a different, a single car. Then you'd have supervisors, and then super supervisors, and you could have up to 60 to 70 people doing timing and scoring. Now we can do a full race weekend for 4 different series with 14 people.
Yeah, I think just the technology capabilities have gotten so much better over time. It's really cool. I'm going to answer one more question, and then I think we have a couple more topics. I know we got 5 minutes left. So the number one question right now is, what is the fastest car? And that's a tough question to answer. I guess it depends. A lot of people would say Formula One, just because they put so much money into developing those cars. I would say IndyCar, because they're able to run on the Indianapolis Motor Speedway and hit insane top speeds, while turning consistently. Some people would say like drag cars, because they're pretty much built just to go fast in a straight line. So I guess it really depends on what mode of racing you're referring to. But there's a lot of fast cars out there that are fast for their own application. Mm-hmm. On that note, I think an interesting topic that I want to get into is some of the future and technology applications of racing that also apply to maybe how it's going to affect the real world and how we commute and get around. Autonomous vehicles. That's been a huge topic in the last few years, to say the least. One of the cool events that just took place actually here in Indiana was the Indy Autonomous Challenge. I was fortunate to have kind of a closer look into that event. And just to give a quick summary for those who are unfamiliar with the event, what they did is they had 10 cars. They were actually old Indy Lights chassis. So everybody had the exact same equipment, except the only portion of the car that was different to one another was the coding and algorithms that college teams and students programmed into their own specific cars that was able to completely drive itself and race around the Indianapolis Motor Speedway, which was, I think, an insane challenge. They were only given, I think, 6 months or something to write this code and come up with this whole program of how these cars would basically drive themselves around the racetrack. I watched it, and the leading team was able to do an average of 140 miles an hour, a car that was completely driving itself around Indianapolis Motor Speedway. Now, I think that the technology, even though this was the first time that an autonomous race car had been around the Indianapolis Motor Speedway and broke the records for maybe top speeds of an average lap for an autonomous vehicle. What's really cool is that the technology that students in colleges were able to put together is going to play a huge factor into how cars on the road and people just driving around, how they communicate with each other, how the cars are able to detect accidents and potential crashes. And really, it's going to change the way the future of driving is. But a lot of that is able to start in kind of a controlled environment that racing provides. So kind of the whole core of racing is really to experiment and push the limits on technology so that we could test and develop certain tools that could help impact and change the world in a better way. And I know Matt had kind of another thing to add to that about smart highways and how those will play an impact in the future.
Yeah, so some of the projects that we're working on now, one of the things that we're trying to get at all of our racetracks is a private 5G network. So they're fairly new right now, but the government has set aside these areas of bandwidth where you can have a private 5G network. And I see this happening on highways around cities and states where you're on a highway. So here in Indianapolis, you're on 465 going around the city, and your car is enabled to connect to this private 5G network. And it knows when there's accidents, it knows when there's slowdowns in the track, it knows where emergency vehicles are, where on your dash and in your car, it's going to give you variable speed limits because it knows how close you are to the car in front. It knows where all the slowdowns are happening. And it's able to tell you, hey, normally this is a 55 zone but there's not much traffic. So now you can go 70 safely and with no issue. Or there's a lot of slowdowns. Hey, it's going to start instead of you going 55, and all of a sudden having to slam on the brakes because you don't know something's around a turn. Now they're going to be able to tell you, hey, it's 35 miles an hour here because there's a slowdown up ahead. It's going to help move traffic a lot better than what it is now because you're not getting that stopping and starting as much. The fuel economy is going to be so much better because you're not doing the stopping and starting, that you're just kind of going at a constant speed because everybody knows what the speed limit is based on the amount of traffic that's in there. And all of this stuff is all stuff that we've been working on for 5 to 10 years. It's, since I've been here, this is all technology we've been doing in racing.
Well, it looks like we just hit the time, but thank you everybody for tuning in. I really encourage all of you to look into some of the technology and the way that tech is being involved in racing. There's really a lot of cool opportunities that are coming up in the industry. So take some time to really look into how getting educated and growing your knowledge in computer science, there are career paths in racing that could really lead to an exciting future, especially in such a cool sport, such as the IndyCar